Section 4.7, Quadratic Formula. So the quadratic formula for equations given in standard quadratic form here, ax squared plus bx plus c, we use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a in order to solve for x. So if we're looking for the solutions to a quadratic function, we can use the quadratic formula. Keep in mind that this is referred to as the universal method. So basically, it always works. It's not the most fun, but it always works. So let's go ahead and practice the quadratic formula, which we saw back in Algebra 1. So in example A here, we've got x squared plus 6x plus 9 equals 0. So in order to use the quadratic formula to get your a, b, and c, you want to make sure your equation is set equal to 0. That's nothing new. So for this first one, we're already set up. So let's just figure out the values of a, b, and c. So a in this case is going to be 1, b would be 6, and c would be 9. So now we just need to plug this into the quadratic formula. So we've got x equals negative b, so it'd be negative 6, plus or minus the square root of, we've got b squared, so that's 6 squared, minus 4 times 1 times 9, all over 2 times 1. So now we just need to kind of simplify this along as we go in order to help us figure out what our answer is. So I'm going to simplify what's underneath the square root first. So as I simplify this, I'll notice that this problem is going to become x equals negative 6 plus or minus the square root of 0 over 2. Because 6 squared is 36, minus 4 times 1 times 9, which is minus 36, so it becomes 0. And so now, essentially, this part of the problem doesn't even matter. So in reality, what we're left with here is x equals negative 6 over 2, which gives us a solution of negative 3. In example B, we're going to do the same thing, except in this case, we need to recognize that this isn't set equal to 0. In order to set this equal to 0, I need to move the 4 over by subtracting it. So I'll subtract 4 from both sides. That gives me 2x squared minus x minus 4 equals 0. Now it's in the right form. So now I'll just identify my a, b, and c values. So a is 2, b would be negative 1, and c would be negative 4. So now I'm going to plug this into the quadratic formula again. So x equals negative b, so it's going to be a positive 1 in this case, plus or minus the square root of, in this case, negative 1 squared minus 4 times 2 times negative 4, all over 2 times 2. So once again, when I start this, I always simplify underneath the square root, just the way I prefer to do this. So x equals 1 plus or minus, in this case, 1 squared, negative 1 squared is 1, and then you've got negative 4 times 2 times negative 4. That ends up being 32. So underneath our square root, we're going to have the square root of 33, or 33 in this case, over 4. The square root of 33 is not a perfect square. It actually can't be reduced. If you were to break this down, it's 11 and 3. Doesn't really help us. We could figure this out and plug it into our calculator and get decimal forms. But for right now, I'm going to go ahead and leave it as 1 plus or minus the square root of 33. But if you want the decimal answers, x in this case would equal, so if you wanted the decimal version, you would just have to type in your calculator 1 plus the square root of 33, then divide that by 4, and then you would do it again, 1 minus the square root of 33 divided by 4. Keep in mind that eventually when we go through these, you'll see that you need to separate your equation for 2 different occurrences because of this plus or minus symbol within the quadratic formula. So let's take a look at the next examples. Here we've got x squared plus 4x minus 3 equals 0. In this case, a is 1, b is 4, c is negative 3. So x equals negative b, so negative 4, plus or minus the square root of 4 squared minus 4 times 1 times negative 3, all of this over 2 times 1. So we'll simplify what's under the square root first. And if I'm not mistaken, 4 squared is 16, and this would be 12, so that would be 28 over 2. 28 is not a perfect square, but in this case, we could simplify the radical. And if you don't remember how to simplify radicals, you're just pulling out. So if we're dealing with simplifying the radical in this case, the square root of 28 breaks down to the square root of 4, square root of 7. 7's prime, so it doesn't simplify, but we can square root the 4, so it becomes 2. So this becomes 2 square root of 7. So if that's the case, we can break this answer down farther. So we have x equals negative 4 plus or minus 2 square root of 7 over 2. Then to calculate these separately, to find our final answer or to simplify them down, what we're looking at here is x equals negative 4 plus 2 square root of 7 over 2, which notice that negative 4, 2, and 2 are all even, so they'll reduce. So we've got negative 2 plus the square root of 7 is one answer. And then if we do the same thing for the other version of this, and I'll have to erase it in a minute when I get to this, we'd have x equals negative 4 minus 2 square root of 7 over 2, and that'll reduce as well. So we've got negative 2 minus the square root of 7 is our other answer. In reality, we could have written this as negative 2 plus or minus the square root of 7. That would have worked as well. We would have just simplified the radical accordingly in the original problem. You can also use these values to create your decimal forms if you want to put them in decimal form. Ultimately, it's up to you. Or actually, it's up to us as the teachers, depending on how we want our answers. So we're going to look at example D. So I'm going to have to erase part of this in order to have room for that. So example D, once again, we're not in the right form. We have to move the negative 4 over. So x squared plus 4x, plus 4 equals 0. Your a value is 1, b is 4, c is 4. So now we're looking to solve this. Well, x equals negative b plus or minus the square root of 4 squared minus 4 times 1 times 4. So here, and this is going to all be over 2 times 1. So now simplify what's under the radical. X equals negative 4 plus or minus, in this case, 4 squared is 16. And then on the right half of this equation here, or this what's under the radical, you get negative 16. So those cancel out. So you have the square root of 0 over 2. So this simplifies down into x equals negative 4 over 2. So x equals negative 2. So sometimes your absolute value equations will have 2 answers. Sometimes they'll have 1. Sometimes they won't simplify. Sometimes they will. It just depends. And sometimes you'll have no solutions if you end up with a negative under the square root. Just depends on what happens. So here we're dealing with a word problem. It says the equation of p equals negative x squared plus 48x minus 300 models the profit of a CD fundraiser. What is the least amount you can charge for a CD to make a profit of $200? So ideally what we're going to do is we're going to plug in this 200 for p. So we're looking at the equation 200 equals negative x squared plus 48x minus 300. Now, we need this to be set equal to 0 for the absolute or for the quadratic formula to work. So I'm going to subtract the 200 over. So 0 equals negative x squared plus 48x minus 500. Now what I need to do is set up and solve my quadratic formula. So remember, a is negative 1, b is 48, c will be negative 500. So x equals negative 48 plus or minus the square root of 48 squared minus 4 times negative 1 times negative 500. Really big numbers here. Good thing we have calculators. 2 times negative 1. So now we're just going to go ahead and simplify this. And I'm going to move it over here. I'm running out of space. So I've got x equals negative 48 plus or minus the square root of 304 underneath the square root. And that's over negative 2. Because we're dealing with what is the least amount you can charge for a CD, we're talking about money here and things like that. We're going to go ahead and try to find the decimal answer to this rather than simplifying the radical. So what I'm going to do now is I'm going to create my two occurrences of this. So one's going to be negative 48 plus the square root of 304 divided by negative 2. And in this case, I'm going to get right around 15.28. That's not great handwriting, so we'll fix that. Then I'll do the same thing. This time, instead of having the plus 304, I will have the subtraction of the square root of 304. Divided by negative 2. And when I do negative 48 divided by the square root of negative 48 minus the square root of 304 divided by negative 2, in this case I get 32.72 roughly. So I have my two answers. And it says, what's the least amount you can charge? Well, that's going to be the $15.28, or in this case, $15.28. Now we're going to talk about the discriminant, which is part of the quadratic formula. The discriminant is the b squared minus 4ac. It's the portion underneath the square root. And this particular portion of that quadratic formula allows you to determine the number of real solutions that your quadratic function has without having to solve it and find those solutions. So one of the things you learned previously is that it can be 0, it can be negative, it can be positive, and each of them have a different meaning. So in this case, if your discriminant in this case is greater than 0, or what we say is positive, then you have two solutions. Better yet, we should probably put two real solutions. And then if b squared minus 4ac is equal to 0, or in this case we'll just say 0, then we have one real solution. And then if b squared minus 4ac is less than 0, or in this case negative, then we have no real solutions. And so just for quick reference, if we were to talk about what these would look like graphically, let's say we have our coordinate planes here, and these are just examples. Two solutions would be something where it crosses the x-axis twice. One solution would be where it just touches it. I missed again. I'm not very good at drawing today. There we go. That's close enough. And then no solutions would be where it doesn't ever cross the x-axis. So if it's positive, we have 2, 0 is 1, negative is no real solutions. So let's see what we can do with this. Here we have 3 different examples. We'll do the first 1 or 2 together, and then third one. We'll do them all together. Fine. So A, B, C. And so we're going to plug this into the discriminant. So remember, the discriminant, b squared minus 4ac. And we're going to see what it equals. So that means we've got negative 3 squared minus 4 times negative 2 times 5. So here we've got 9. And then here, plus 40. So our discriminant in this case is 49. Since it's positive, that means we have 2 real solutions. We'll do the same thing for example B here. We've got our A value, our B value, and our C value. So negative 3 squared minus 4 times 2 times 7. So 9. In this case, we've got 56. And then this is going to be negative 47. So that's negative, so it's no solutions. And then last but not least, example C down here. Notice that C isn't written in the right form. It's x squared equals 6x plus 5. So we have some options. We're just going to try to get this set equal to 0. So the easiest way to do this would be to move the x squared over. So that would be 0 equals negative x squared plus 6x plus 5. So now we have our values for A, B, and C. So in this case, A is 1, B is 6, C is 5. So we're going to plug this into the discriminant again. So 6 squared minus 4 times negative 1 times 5. So here we have 36, and then we've got plus 20, so that's 56. So since, again, it is positive, we have, whoops, wrong color. We have 2 real solutions. All right, last problem here. The function h equals negative 16t squared plus 85t plus 1/12 models the height and feet of a ball at the time t in seconds. Will the ball reach a height of 115 feet? So we can actually use the discriminant to solve this without actually having to solve it. So what we're going to do here is we're going to plug the 115 in for h here, and then use the discriminant to tell us how many solutions this equation would then have. So in this case, we've got 115 equals negative 16t squared plus 85t plus 1/12. So now our goal would be to move over the 115. I mean, this is not going to be a great equation, so we'd subtract it. That gives us negative 16t squared plus 85t minus 114 and 11/12. And so now we're going to go ahead and use the discriminant to solve this. And I recommend using your calculator for this because it could get messy. So we're going to plug this into the discriminant, so b squared minus 4ac. And with that, we're going to get 85 squared minus 4 times negative 16 times negative 114 and 11/12. And so if we crunch all this on our calculator, we end up getting that our discriminant in this case is negative 129, and 2/3. Since the discriminant is negative, that means we have no real solutions based off of the 115 we plugged in, so it will not reach 115 feet.